Hello all, myself Devendra Itole, working as an assistant professor in ENTC Engineering Department from AISSMS Institute of Information Technology Pune. Today's topic is EUSART of PIC microcontroller, means Enhanced Universal Synchronous Asynchronous Receiver Transmitter of PIC microcontroller. The Enhanced Universal Synchronous Asynchronous Receiver Transmitter module is one of the two serial modules. The USART is also known as Serial Communication Interface or SCI. The USART can be configured as full duplex asynchronous system that can communicate with peripheral devices such as CRT terminals and personal computers. It can also be configured as a half duplex synchronous system that can communicate with the peripheral devices such as A to D or D to A integrated circuits, serial EPROMs, etc. The enhanced USART module implements additional features in PIC 18, including automatic baud rate detection and calibration, automatic wake-up on synchronous break reception, and 12-bit break character transmit. This make it ideally suited for use in LIN bus, local interconnect network bus systems. The EUSART can be configured in the following modes: asynchronous full duplex with auto wake up on break signal, auto baud calibration, 12-bit break character transmission, synchronous master half duplex with selectable clock polarity, and synchronous slave half duplex with selectable clock polarity. The pins of EUSART in PIC 18 with port C. In order to configure TX and RX as an EUSART bit SPEN, that is 7-bit of RC-STA register must be set. Then TRS 7-bit must be set, and TRSC 6-bit must be set if you want to configure the EUSART of PIC 18. These 3 bits must be set. The operation of enhanced USART module is performed using the following registers: serial port baud rate generator, that is SPBRG, transfer buffer register TXREG, and receive buffer register RCREG, transmit status and control register, receive status and control register, peripheral interrupt register, baud rate control register, BAUDCON. PIC 18 transfers and receives data serially at many different baud rates. Baud rate means the rate of data transfer in serial data communication is stated in BPS, bits per second. Normally is called as a baud rate. The baud rate in the PIC 18 is programmable. This is done with the help of the 8-bit register called SPBRG. For a given crystal frequency, the value loaded into the SPBRG decides the baud rate. TXREG register. TXREG register is another 8-bit register used for serial communication in PIC 18. For a byte of data to be transferred via TX pin, it must be placed in TXREG register. Then the TXREG is a special function register and can be accessed like any other register in PIC 18. RCREG. Similarly, when the bits are received serially via RX pin, the PIC 18 deframes them by eliminating the stop and start bits, making a byte out of the data received and then placing it in the RCREG register. Next, TX STA register, that is transmit status and control register. This TX STA register is an 8-bit register used to select the synchronous asynchronous modes and data framing size, among other things. The BRGH is used to select the highest speed for the transmission. As we can see, it's a 8-bit register, starts from bit number 0 to 7. Bit number 7 is CSRC, that is clock source select bit. When the USART is used in this configured as a asynchronous mode, this bit is don't care. But if you are using the synchronous mode, then clock generated internally from BRG, this bit is set, and if it is equals to 0, then clock from external source is get selected. 6th bit is TX9, that is 9-bit transmit enable bit. If it is set, selects a 9-bit transmission. If you are transmitting 8-bit data, then this bit should be 0 or clear. TXEN, 5th bit, it means transmit enable bit. When this bit is equals to 1, transmit is enabled, otherwise it is disabled. SYNC, USART mode select bit, whether you want to select a synchronous mode or asynchronous mode. If you want to select a synchronous mode, this bit is equals to 1. If you want to select a asynchronous mode, this bit is equals to 0. Next, 3rd bit ACNDB, send break character bit. In asynchronous mode, if this bit is equals to 1, then send synchronous bit break on next transmission. This is cleared by the hardware upon completion. If this bit equals to 0, the synchronous break transmission completed. And for the synchronous mode, this bit is don't care. 2nd bit BRGH, high baud rate select bit. In asynchronous mode, if this bit equals to 1, it will work at high speed. If it is equals to 0, it will transmit data at a low speed. In synchronous mode, it is not in used. 1st bit TRMT, transmit shift register status bit. If this bit is equals to 1, transmit shift register is empty. If this bit equals to 0, transmit shift register is full. 0th bit TX90, 9 bit of transmit data can be address or data bit or a parity bit. Then RCSTA, receive status and control register. The receive status and control register is an 8-bit register used to enable the serial port to receive data, among other things. It is a 8-bit register, bit number 7, named as a SPEN, serial port enable bit. If this bit is equals to 1, then serial port is enabled. If it is equals to 0, serial port is disabled. 6 bit is RX9, it means 9-bit receive enable bit. If you want to transmit or receive a 9-bit data, this bit equals to 1. If it is 8-bit data, this bit is equals to 0. 5th bit SREN, single receive enable bit. In asynchronous mode, it is not in used, don't care. And in synchronous mode, 1 master, 1 equals to enable signal receive, 0 equals to disable a single receive. This bit is cleared after reception is complete. 4th bit, that is CREN, which means continuous receive enable bit. In asynchronous mode, if this bit equals to 1, it enables the receiver. If this bit equals to 0, disables the receiver. Synchronous mode, in synchronous mode, 1 indicates enables continuous receive until enable bit CREN is cleared, and 0 disables continuous receive. Third bit, that is ADDEN, address detect enable bit. In asynchronous mode, 9 bit, that is when x9 equals to 1. If this bit equals to 1, enables address detection, enables the interrupt, and loads the receive buffer when RSR 8 bit is set. And if it equals to 0, disables the address detection. Second bit, FERR, framing error bit. If it equals to 1, framing error is there. If it is equals to 0, no framing error. Then first bit, overrun error bit. If there is overrun error, then this bit is get set, otherwise it is 0. RX 90, last bit, 9 bit or received data, that this can be address bit or a parity bit and must be calculated by user firmware. Then Baud register. This Baud register is again of a 8-bit register. Starts from bit number 0 to bit number 7. Bit number 7 is ABDOVF, auto Baud acquisition rollover status bit. Okay. If this bit equals to 1, a BRG rollover has occurred, and if it equals to 0, no BRG rollover has occurred. Then 6 bit RCIDL, receive operation ideal status bit. If this bit equals to 1, receives operation is ideal. If it is equals to 0, receive operation is active. Then 5th bit RXTTP, it means data receive polarity select bit. In asynchronous mode, if this bit equals to 1, it received data is inverted, and if this bit equals to 0 in asynchronous mode, received data is not inverted. Same is for the synchronous mode also. Then 4th bit TXCKP, clock and data polarity select bit. In asynchronous mode, when the asynchronous mode is selected, if this bit equals to 1, ideal state of transmit is a low level. If it is equals to 0, ideal state of transmit TX is a high level. In synchronous mode, 1 indicates ideal state of clock is high, and 0 indicates ideal state of clock is a low level. Then BRG 16-bit baud rate register enable bit. 1 indicates 16-bit baud rate generator. Here SPPRGH and SPPRG is going to be used, and if you are generating 8-bit baud rate, then this bit equals to 0. At that time SPPRG only is used and SPPRGH value is ignored. Second bit is reserved, don't care. First bit WUE, it's a wake up enable bit. In asynchronous mode, EUSART will continue to sample the RX pin, interrupt generated on falling edge, bit cleared in hardware on falling rising edge if this bit equals to 1, and if it equals to 0, then RX pin not monitored or rising edge is detected. It is not used in synchronous mode. Last bit ABDEN, auto Baud detect enable bit. In asynchronous mode, this bit equals to 1, it enables the baud rate measurement on the next character, requires reception of a synchronous field 55H cleared in the hardware upon completion. And equals to 0, baud rate measurement disabled or completed. It is not used in the synchronous mode. Then PIR, peripheral interrupt request register. Two of the PIR1 register bits are used by the USART, the RTX-IF transmit interrupt flag and RCIF receive interrupt flag. We monitor the TX-IF flag bit to make sure that all the bits of the last byte are transmitted before we write another byte into the TX-REG. Next, baud rate formula. The table shows the formula to generate a baud rate. Here, when synchronize SYNC equals to 0, BRG16 is equals to 0 and BRGS equals to 0, then 8-bit asynchronous mode is selected. For that, baud rate formula is FOSC divided by in square bracket 64 in bracket n plus 1 bracket close. If SYNC equals to 0, BRG16 equals to 1 and BRGH equals to 0, then 16-bit asynchronous mode is selected. At that time, baud rate formula we have to use FOSC divided by 16 in bracket n plus 1 and so on. Next, PIC 18 connection to RS232. A diagram shows the connection between the RS232 and microcontroller, and RS232 is connected to the computer. PIC 18 has two pins that are used specially for transferring and receiving data serially. These two pins are called TXD and RXD and are part of the port C group RC6 and RC7 of 14-pin IC. Pin 25 of the PIC 18 RC7 is assigned to the TX and pin 26 RC6 is designated as RX. These pins are TTL compatible, so therefore they require a line driver to make them RS232 compatible, because PIC 18 or microcontroller knows the TTL logic level and RS232 doesn't know the TTL logic. Therefore we require a line driver to make them RS232 compatible. So one such line driver is the MAX232 chip. Because the RS232 is not compatible with current controllers, we need a line driver, that is a voltage converter, to convert the RS232 signals to the TTL voltage levels that will be acceptable to the PIC 18 TX and RX pin. The MAX232 converts from RS232 voltage levels to the TTL voltage levels and vice versa. One advantage of the MAX232 chip is that it uses the plus 5 volt power source, which is the same as the source of for the PIC 18. So there is no need to use the dual power supplies. Thank you.